Hello friends, in this video we are going to look at problem 395, longest substring with at least key repeating characters. So for this problem, actually we can solve it easily using recursion. And here also we can use two-pointer sliding window method to address this problem. So first we are going to write a solution using recursion to digest the requirement. And then we are going to continue on our main purpose, that is to explain two-pointer sliding window method or trick here. So actually we practice another problem, that is 2958, before we do this problem or practice this problem. That is the length of longest subarray with at most key frequencies. So it's actually good to compare these two problems. And meanwhile, we have a playlist called two-pointer sliding window method in our channel. You are also welcome to check those problems out. So with that said, let's look at the problem here. First, we're going to look at the requirements. It's very short, and then we look at the coding. So here we're given a string s and an integer k, right? So we want to return the length of the longest substring of s such that the frequency of each character in this substring is greater than or equal to k, right? So if you look at the first example, you see A appears 3 times and B appears twice. So this actually tells us directly, so in our substring or valid substring, in the sense of this problem, we cannot include the letter B, right? Because B appears at most twice. So in this case, we could only collect the 3 A's, so the output is 3. Well, in the second example, you see A appears twice, B appears 3 times, while C appears only once. So in our result, we can only contain at least at most A and B, right, simultaneously. But here we can have AB, ABB. So here A appears twice and B appears 3 times. So the length will be 5. So this frequency analysis or count, like here B appears twice, we cannot include it. Here C appears once, we can also not include it. So it actually gives us some hint on how to do two-pointer sliding window. So here the length of this string is bounded above by 10 to the power 4. So this number is not that small or not that large. However, if you use n square time completed solution, it might not pass all the cases. So here S consists of only lowercase English letters, and the k is in between 1 and 10 to the power 5, right? So notice that if k is 10 to the power 5 and S is length is 10 to the power 4, so no characters actually appears k times. So this is also a trivial case. So this actually gives us some hint on how to do recursion. So with that said, we are ready to analyze the problem. So our purpose, as I mentioned at the very beginning, is not to solve this problem itself. It's rather straightforward to solve it as. So we are going to analyze. First, I'm going to give a solution based on recursion. So this is rather straightforward. First, I'm going to get if the length of this S is less than k. So in this case, no characters appear k times. So we just need to return 0. So this, if I use recursion, let's see. This is the base case, right? So another one is that we can consider the frequency of these characters in C. Let's see. Given a character, so let's find the least frequent character. Let's see. So we can use this set will give us the unique characters in S. And then we are going to count according to a key. So you can use a lambda function, or you can see just S. So because S is a string, we have a count method, right? So we want to find the smallest frequency character. For example, in the example 1, that will be B, right? So then we have this information. So then we can get another case, base case. If S count C. So notice that the frequency of C is the minimum in S. If this is greater than or equal to k, right, then it means every unique character appears more than equal at least k times, right? We just need to return the whole s. So this is another extreme. But in the middle case, that's exactly our recursion, right? So we just need to return the max of, so self, let's call this longest substring. Then what are we going to do? So we're going to s and k. So here, let's not write s as t, right? For t in, so we can split this string because we cannot include b or c here, as in example 1 and example 2. In s, split. So with this character c, right? Then this will reduce the after you do the split. For example, you split at b, you are going to get AAA empty empty, right? Then AAA will be the one corresponding to this case, right? So then you do the split, it will reduce to the base cases, either this one or this one. Then you are going to get the return the maximal, right? So this forms a solution format, right? So now let's see. This is the base case for the recursion. Base cases, let me write like this. And then in this one, we have self call and the argument, and is towards the base cases, right? So these are the three ingredients in typical recursion, right? That is base case, self call, and towards the base case. So let's do a test. Here it's not support between instance int and here sc. This means that s count the character greater than still here. So t for t in s split. Let me not support between instance of integer and string. So here we have so here we cannot return s, so we need to return the length of this s. So now let's do the run. Yeah, it passes the first one. Now let's look at the generic case. Yeah, it passes all the generic cases very fast. So that's basically the recursion part. So now let's do our main job. That is the practice for two-pointer sliding window method. So here I'm going to use two-pointer sliding window trick. But for this problem, so there's no obvious order relation or monotonicity relation as in this problem 2958, but still we can do the job. The reason is that, so here you can think you given each of the valid substrings, it have a left and a right, but you know you can consider each end index, and then but you know in this case we don't know at the very beginning. We don't know how to expand or shrink, right? So this one way to address this, this is to consider how many different, how many unique characters are included in the potential valid substring. So we check all the cases, right? For example, if the string contains 2 unique characters, we can consider strings that contain 1 unique character, strings contains 2 unique characters. So actually we didn't quite use how the frequency in this two-pointer sliding window method, but let's first look at the code, and then we can walk through you some example. So here what I'm going to do is this. First I'm going to get the collections see, I can use a counter, right? Let's see. Let's use this m as the length of s. This is just for convenience. And then also we can get the character frequencies. So this we can use a counter, so collections counter, right? So s. So this will give you the unique character in the s and their frequency. So actually we can only include the frequencies with frequency greater than or equal to k. But now for the current problem, we are going to check all the cases, because at most we have 26 unique characters, not even consider the specific string s. So the number of unique characters in the string s will be the length of this dictionary character frequencies, right? So now I'm going to first get a maximum length. I'll set it to be 0. And then we can check all the possible substrings with one unique character, with 2 unique characters, with this amount of unique characters, in other words, length, right? So basically for max allowed unique characters, so I'm going to consider it's 1, or so we can consider 1, at least 1, because it's not empty, and then the length of this character frequencies. So in order to include this, I'm going to write it as at 1. So then basically for each of this allowed character, we are going to run 2-pointer sliding window. Run 2-pointer sliding window method. So because of the fact that we first specify the number of maximum allowed unique characters, we impose the monotonicity. In other words, we know how to do expand and shrinkage. So now let's run this procedure. So first, I'm going to get a character frequency or window, right? So it's going to be we can use a dictionary. Let's see, collections default dictionary. So in other words, this character frequency is a counting dictionary. And then the current unique characters. So it's going to be 0 because we haven't started yet. So now we can use left to be 0, right? Start. And then we're going to do for r in range length of this string. Then we're going to add new character to the window, right? So we're going to see character frequency. This s and r is incremented by 1, right? So here we don't need to check if this k is inside this character frequency because we are using some defaults. So now with that said, we also want to monitor the number of unique characters in the window. So basically, if character frequency, so SR is 1, right? Then it means that the current unique characters is incremented by 1. Current unique characters is incremented by 1. So next, basically, we do the shrinkage, right? So basically, if you add too many unique characters, it will be larger than the maximum allowed unique characters. So this will be the pushing L to the right. So what we are going to do is that, well, current unique characters, this is the count, is larger than max allowed for unique characters. Let me copy this part. Then what we are going to do, we are going to remove the character from left until this condition is satisfied, right? So basically, character frequency. So the S L is decremented by 1, right? Then after decrement, maybe the frequency becomes 0, right? If, let me copy this part. So if this character frequency is 0, then we can del the corresponding key. So then this is the main logic, right? Then afterwards we can we can increment this L by 1, right? So afterwards, basically we get a window between L and R, right? So such that in this window, so we have a substring that has this number of unique characters or less, right? Then we want to check if this window starting from L and R, so say L and R corresponds to a valid substring. So for this, we just need to check the frequencies of unique characters in between, right? So basically, we can check so the mean frequency, right? So let's see if mean character frequency values, because the value is the frequency. If this frequency is greater than or equal to k, right? So it means that this will be a valid good substring. Then we are going to update the maximum length. So the maximum length will be the max of its previous state, and the current one. The current one will be R minus L plus 1, right? And then afterwards, so we just need to return the maximum length. And this forms another solution format. So before we make any comments, let's first do a test. So this here, string index out of range. So let's see, character frequency SL. So let me see, L is 1. So for R in range N. So this is the first increment 1. Then here, character frequency S and L is decreased by 1. So, oh yeah, here, I guess. Well, so we increment L by 1. Let's see, here we have R in this range. Let's see, this is correct. And then we have character, include this current character. And then if the character has frequency 1, so we increment the unique count. So this one, we are going to character frequency. So because we want to shift L to the right, so SL, so it's decremented by 1. And then we are going to, if this one is 0, we are going to delete that. And then we are going to increment this. Oh yeah, I guess here. Oh yeah, here I guess the number of unique characters will also be, because now it's 0, right? If it's 0, it means that the maximum current unique characters is decremented by 1. So current unique characters is also decremented by 1. So now let's do a test. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the generic cases. So now let me come back to this problem again, right? So here, actually, we first get all the unique characters, and then we, for each number of allowed unique characters, actually we run the 2-pointer sliding window method. So this way, the monotonicity actually is imposed by the maximum allowed unique characters, right? So for each round, if we run this 2-pointer sliding window method, it's a linear algorithm. But overall, we have at most 26 characters. So the time complexity will be O of say a length set of s, the unique characters, times the length of this s, right? So I guess here we provide just one example to to impose monotonicity to the problem. And actually here it's good to compare with 2958, right? So that you can get a genuine understanding for this kind of a trick. So with that said, I guess that's about it for this video. Thank you.